It's my great pleasure to have Josh and Jane today with us. They're coming from Mozilla. If you've used Firefox, you know what Mozilla is. So Josh is a person I actually met over a call that Pete and I were having about trying to do speech commands, which you're going to read about, for 1,000 different languages. Totally crazy and totally ambitious. It was an informal sort of meetup, but then I kind of learned about the kind of stuff that Josh does. And as it says here, Josh, who's got a PhD, works at Mozilla as a lead scientist working on speech technologies. He's got a lot of experience in ASR-related things. Hopefully you've read the Common Voice paper. If not, I assume you'll be reading it pretty soon. There's a lot of stuff in there that actually kind of builds on the Common Voice pipeline. I'm hoping that they'll talk about that. And it's also great to have Jane, who's a product lead at Mozilla, who oversees things related to Common Voice. I'm going to let them introduce themselves, but I can tell you for a fact that it's a great pleasure to have them because we've actually been working with both of them behind the scenes. So Josh and Jane, welcome. Very much appreciate you making the time for the students. And with that, I'm going to stop sharing my screen, and then I'll let you all take whoever decides to present.
Awesome.
Yeah.
Thanks so much, Vijay. Yeah, and I think Josh is going to share his screen, but then we'll definitely kick off.
Yep. Sharing.
If there are questions and so forth, keep them coming in chat, and then the TAs and I will watch over, and then we'll ping Jane and Josh on the fly.
Yeah, sounds good. And Josh and I can tag team on questions as well. So thanks so much, Vijay. It's great to be here. Great to connect with all students chatting about Common Voice. I do have one minor correction, just Vijay, on one of your slides. You mentioned that we're industry experts. I don't know who you're talking about, but that's not the expert. That's not us. But it is really exciting to be here. Common Voice has been something that I've been working on for a little while now, and really excited to share more about the platform. Josh has been diving deep into the data, building really cool models, and really exploring data in all of its forms and all of its manifestations, and how we can make sure it's balanced. So really excited to dive in. So Josh, I'll let you progress on. So as Vijay mentioned, I'm a new product lead at Mozilla, so that can take all number of hats. So my days look very, very different. At the moment, voice is one of the big areas that I'm focused on, but also starting to dive into some privacy and security work, all that kind of jazz. Mozilla is a great place in that, every day is a little bit different. All the things that we get to play around with, and we get to explore. There's no shackles, no restrictions. So having that opportunity to really stress and test around what products can be most impactful is really exciting. You can email me. I'll get back to you as soon as I possibly can. In this COVID times, email seems to be the default form, even though I much prefer that sort of face-to-face, that kind of dynamic. Follow me on Twitter, and I'll let Josh introduce himself quickly.
Yep. So as Vijay said, my name is Josh. I am a machine learning fellow at Mozilla, which means that I'm working on some specific projects with Jane as well, doing some speech technology for a couple of East African languages. And also my kind of day job is a lead scientist for speech technologies at a startup in Los Angeles called Arty. So I have experience doing ASR, speech recognition, speech synthesis, NLP, kind of all things language technology, and I have a very special place in my heart for underserved language technologies. My dissertation was about multitask learning and transfer learning, specifically for underserved language speech recognition. So you can think of trying to take a big model from English that's been trained on thousands of hours of data, and looking at how we can fine-tune that when we only have 5 hours or less in some new language. And yeah, if you want to get in touch with me, here's some points of contact. And with that, I'll let Jane get back to the intro.
Awesome, thanks. So what we'll run through today, I'll provide a little bit of an overview of Common Voice, sort of the features and capabilities of the platform, and then dive into why is it important? Why did we decide to do this? Then I'll pass back over to Josh, who will be diving deep into the speech ML side of the world and into the data, and particularly into this target segment that we've collected recently, and dive into the data there. I do want to make sure we have more than enough time for questions if they come up, but feel free to ping as we're chatting if you want to sort of line up some questions. I want to make sure that you are engaged and involved in the conversation because it's something that we're really excited and passionate about. Next slide, Josh. Awesome. So what is Common Voice? Common Voice is, at its very essence, a crowdsourcing data platform. So we've created a platform such that we can activate community members, whether they're existing Mozilla community members, new community members, or language communities, to contribute their voice. This is part of the Common Voice. At a larger scale, it's more than just the platform. It's the data set that grows and evolves. It's the community that supports and encourages each other. And it's providing that data to machine learning researchers and engineers around the world to start to build new and interesting tools, trying to democratize voice tech through that application of data. Yeah, there we go.
Good.
Cool, thanks. When we sort of took a step back and we're looking at the voice tech space, we saw a couple of things to be true, and I'll dive into these a little bit later as well. But there's a hypothesis that in the future, all interaction will be done by voice. So, especially in COVID times, right? It'll be so great to be able to go into an elevator and just control it with your voice, as opposed to having to touch any buttons anymore. And so voice will be the new keyboard. The keyboard is ubiquitous, but now soon we'll be able to sort of control things with our voice in a more robust and complex way. However, the journey to get there, as you all know, data is the lifeblood of any ML model, is the lifeblood of any of these kind of technologies. And there was a lack of publicly available data to be able to build these models, to build robust models. So what could we do? We wanted to find a way to capture the imagination of our community, to start to contribute their voices, validate those voices, and be an active part in building technology and tools for their specific communities. So an active way of democratizing voice tech. To the next, yeah, perfect. So we've had sort of considerable success over the last 3 years in doing this. So going from absolutely 0 seconds of data and a platform that sort of struggled at the best of times with high volume of use, to having over 8,700 hours of voice data, which is considerable, right? That's a good, strong corpus to be able to build models on.
Jane, there's a quick question that's actually quite relevant.
Oh,
So
yeah, absolutely.
earlier you said that speech is going to be everything, right? And Alex is asking, how would that work from an accessibility standpoint if everything is voice controlled?
Oh, 100%. And that's a great question, because one of the things that we do think about is sort of differently abled individuals and how they interact with technology. In the same way that we need to adjust and design for differently abled currently. So if someone's blind, having a screen reader, or et cetera, we would do something. It would be a similar application in the voice domain. But I think it's a real concern, and we've had some really interesting and robust conversations with research groups that are looking at speech pathologies or people who have different speech afflictions, and how to build and design voice tools for them. So I think it's still an open question, but it's a great question. Awesome. One of the things that we are really excited about is the reach on the contributors. So we've got quite a lot of, quite a robust community that's built around sharing their voices, validating their voices, contributing to the code, using the data sets. And that number keeps on growing and growing and growing. We want to, so that the sort of the value proposition, or that approach of how can I contribute to building technology for my community, for my language, for my society, really resonates well with people. One of the things that I'm excited about with Common Voice is also the spread of languages. So Josh, if I can get you to go to the next slide. There are over 57 languages that are on Common Voice and more that are in the pipeline, and I'll sort of talk about the pipeline in a little bit. But this shows a broad interest from a way beyond just the sort of the base languages or the main languages, and we really like to see the growth that's happening in some of these other languages and even accented major languages. So I'll walk through very quickly the some of the features of Common Voice, just so you can understand the workflow of how people sort of interact with it.
Question on the previous slide on the
Yeah, absolutely.
So EN is obviously English. What's the RW here?
It's Kinyarwanda. So one of the projects that Josh mentioned is doing work in underserved and under-resourced languages in East Africa. And so in the past year, we've had a really big push in Kinyarwanda, and we've seen the community grow and flourish.
I'll just add something here really quick, is that these top languages are not the top languages you see in a lot of other statistics, number of speakers or gross domestic product. These are languages that have a lot of community activation. So we've got English is the largest, but then we have Kinyarwanda, German, French, and then Catalan. Catalan has actually got a huge community supporting this. And then we have Kabyle, which is a Berber language from North Africa. And then Esperanto, I'm pretty sure. So we've got a lot of languages here that it's a really unique kind of diversity driven by the community.
Bingo. Right. So this is not dictated by anyone in terms of what are the priority languages. This is the communities responding, and there's a mix of communities that see that there aren't technologies built for them or voice technologies built for them. Communities that are prioritizing language preservation is a really interesting use case. But yeah, exactly.
I mixed up Spanish. So ES is Spanish, not Esperanto.
Cool. On to next. So these are just sort of the features of the platform, which also sort of exposes some of the data pipeline. As Josh mentioned, so the precursor step for some of this stuff is getting the sentences, and you need sort of a considerable number of sentences to start recording because you need to have enough data. But you can record your voice as a user, so gives you a snippet. Josh is right. Sort of a lot of the text on the site is scraped from Wikipedia, but we do have tools to be able to ingest sentences from a bunch of different places. So the European Public Library lists all of the the parliamentary outcomes. So those are all, or the EPL, so we can pull those sentences in. So there's lots of different ways to get those sentences. So donate the voice. So I sort of speak that snippet. A really important step in the flow, which is the next slide, is the validation. So when an engineer, researcher takes this data, they want to make sure that what is said is actually what is written, so that there is that accurate coupling. And so using the community to make sure we're also validating those clips. What we saw when we originally started was that there's a lot of contribution, not a lot of validation, and validation is that really key part to make sure that data is as useful as possible, like high utility. So we worked with communities to encourage more validation, and now we've got a 2-to-1 ratio of people who validate to people who record, which is really great to see because you need to have some multiple validation data points. Another obviously important part of the sort of, if you think about Common Voice as a double-sided marketplace where you've got the data contributors and the data consumers, is to download and use the data set. So we want to make sure that all of the voices that are being contributed are being used and being built into models. And Josh will be obviously running through a whole bunch of this in his slides as well. And then obviously, we're all speaking in English, and we can all probably use websites in English, but some members of the community who are contributing their voice can't do that. So a really important component is the localization of Common Voice as a platform, which is sort of a robust engineering challenge in and of itself, to make sure that all of the tags and the text in the platform itself are translated for users of that community. Obviously, if we're engaging with a large community, there is a lot that comes along with that, a lot of responsibility in that sort of crowdsourced space. So one of the things we've also stood up, which is on the next slide, are our participation guidelines. So making sure that our communities are supportive, encouraging best behavior, and there's a lot of highs and lows that come along with having communities. So I just wanted to share these with the class to understand the nuances that come along with something like crowdsourcing data versus something like paid, which is very contractual and very transactional. Awesome. So that's Common Voice in a nutshell-ish, but I do want to dive a little bit more into sort of the why do we do this? Why is this important? As I mentioned, because obviously this platform doesn't exist in splendid isolation, despite the fact that we're all in COVID. It exists in this ecosystem of voice tech. It exists in this ecosystem of how people interact and engage with technology. So as I mentioned previously, in the future, folks won't type the interaction that I have with my technology through keyboard or through text base that's not going to be the standard, that's not going to be the norm. My voice will be able to control my computer, my phone, but also maybe my doorknob or my fridge, my car, etc. And we're starting to see that sort of evolution now. There's going to be a big sort of uptick as that technology starts to get stronger and better and stronger, but right now it's very sort of, speech technology is very, very good for a sort of more limited command control number of use cases, but it will start to uptick. But what does that mean? That means that my voice will act as the control layer, and whoever controls that API or controls that speech layer is going to control the interaction between user, me, and everything else, and can pick and choose where those controls and those directions are being sent. We're starting to see some early signals from courts and from regulation around what does this actually mean. So if one company or a handful of companies control that speech layer, what does that mean in terms of anti-competitive behavior and all that sort of stuff? So I'm sharing this article, and I can ping. This came out sort of maybe 6 weeks ago or so. So I can pop the article in the chat as well. But these are early questions that are being asked around the technology. Now we know that everyone in this class knows that data is the sort of the fuel that makes the engine run for machine learning. One of the big competitive advantages for large companies is that they do have either access to this data, or they have the funds available to acquire this data and to then build the technology. And so that's where Common Voice sort of comes in and says, hey, let's try to find a way of bringing community to the table and democratizing voice tech by having that publicly available data so that anyone can build models, not just companies who have the resources to be able to do it. On to the next slide, please. And again, this is just a quote from, maybe I should have put a quote from a sort of Harvard Business Review rather than an MIT. Just about that voice API is that central control layer. And then the other important part that drove the sort of nexus of this project was the fact that there's voice technology for, I think it's 0.1% of languages in the world. There are 7,000 languages. We've seen robust STT models for 71 languages, but that also includes accented predominant languages, so like accented English, different versions of Arabic, as was mentioned, and voice technology or access to that control layer shouldn't be limited to the people who speak only those 0.1% of languages in the world. So democratizing not just from implementing the technology, but democratizing across the spread of languages that exist in the world, this beautiful, multicultural, diverse planet that we live in. So that's a bit more about the why for Common Voice and what sort of motivated and drove us to build the platform and provide that public good, that public asset. If there are no questions on that stuff, last one.
Yep. So if there's no more questions about this section, I can jump into a very, very high-level speech machine learning in a nutshell. And this is just a high level to kind of give you an idea of why Common Voice, what place in the pipeline when it comes to applications does Common Voice hold. So we are going to talk about a voice assistant here because that's the kind of most concrete thing that application that we talk about. So for what I would call a minimum viable voice assistant, you need a few different parts to make the interaction possible. Each of these numbers you can think of, except for really number 1, numbers 2, 3, 4, and 5. These are all places where you would have probably at least one machine learning model. So let's say you've got a voice assistant living on your Raspberry Pi. There's a microphone which connects to your Raspberry Pi. You talk into it. That's the speech I/O. And then once the speech has been captured, it's on the device, you're going to take that speech and turn it into text. Hopefully the text corresponds to what the person actually said. You don't want random text, right? So that's what speech recognition does. Then once you have text, you want to understand what was said, what was the meaning, what was the intent. There's lots of different things that natural language understanding are, but that's the basic idea. You have text and you want to extract some meaning from it. Then you have a lot of rules for your voice assistant, but you probably want at some point that assistant to talk back to the user. And that's where natural language generation comes in, and this can be something super fancy or it can be just a rule-based system. But once we get text, we know what we want the assistant to say, then we have to turn that into speech, and that's where speech synthesis comes in. So this is super high level, but it demonstrates kind of the basic parts of the pipeline. And something that I want to highlight is we're talking right now about the Common Voice project, which is specifically for collecting data to train models for the speech recognition part of this pipeline. We're not doing things for NLU or NLG, and we're not doing things for speech synthesis. You can use the data for speech synthesis, but you're probably not going to get something that you like because speech synthesis data is usually from a single speaker. You need a lot of data, and you need it from a very high quality, controlled acoustic environment. Think of a sound booth. Let's say you want, at least 10, 20 hours from somebody in a sound booth to get a synthetic voice that's usable. But for speech recognition, what we're talking about, you need lots of different voices, you need lots of different accents, you need lots of different noises, background noises. So that's what we're talking about, and that's kind of the part that Common Voice fills. But first, I want to talk about what Common Voice isn't the first speech corpus ever. There's lots of other speech corpora out there. I know that you all are going to be talking about and using the speech commands data set from Google. But also kind of historically, there's been this trend in speech corpora that are accessible to researchers, to industry folks, that you get them kind of from some kind of academic background. So these are kind of the most common corpora out there for English, for what we would call large vocabulary speech recognition. They're not a limited set of words. These are just people talking. So there's some kinds of issues here with the LDC corpora. They don't have super open licenses. They're usually pretty expensive if you don't have an agreement through your university. And Libre Speech, which is kind of the most comparable open corpus, is made from audiobooks. So that kind of speech, like the question that came up earlier, this is read speech, but it's even more limiting because it's read speech from people who are basically amateur or professional voice actors, and they're making audiobooks for people to go out there in the public domain. So it's not really the kind of audio that you expect from most applications. So that's a super high overview of the pipeline and where Common Voice fits into it. So at this point, I think I'll dive into this specific subcorpus that we're talking about. We're talking about this target segments, as we call it, corpus. It's downloadable separately from the main common voice corpus. And it's special. It's collected in a different way. So if you went and you donated already to the Common Voice platform, you probably read out whole sentences. But there was, and it continues, a special kind of drive, a special effort to collect this subcorpus called target segments. So what is the target segments corpus? It is, at a basic level, it's a corpus, a data set of speech and transcriptions of that speech. And there's other kind of annotated data that I'll get into, but that's the core of it. It's a bunch of audio files and the transcriptions for those audio files, and they're aligned. It consists of 18 languages. It's currently at about 120 hours of audio, and it only has 14 words. So this is the point where I kind of want to talk about the kind of origin story for why we wanted this corpus in the first place. I think most of you all might be interested in this corpus as a set of data that you can use for training small models that are able to recognize a small vocabulary for some kind of command and control. 14 words, they're isolated words, they're not in sentences. That's kind of the basic target application. However, the original thinking was we want to kind of have a nice benchmark. We originally thought of this as a testing corpus, not as something that you could use to train models with, but now it's grown enough that it's definitely something you can use to train. And comparing languages for accuracy or word error rate, as it's usually reported in the speech literature, it's hard because languages have different, words are different in different languages. Words, some languages might have very long words that one word might be translated into 7 words in another language. And so it's kind of apples to oranges comparison. But when it comes to these words, the ones that we're collecting, the single digits, 0 through 9, yes and no, and then hey, Firefox. These words, the thinking was, at least for the numbers and the yes, no, they should be cross-linguistically pretty comparable. Comparable in terms of their frequency, like how often people say these words, because how often you say a word has an effect on pronunciation, and also the kind of number of syllables. You don't often see languages where the number 3 has, 8 syllables, right? They're usually kind of shorter, like 2 or 3 syllables, maybe even 1 syllable. Yes and no actually is not as cross-linguistically comparable as you would think. Celtic languages like Welsh, which we have data on, don't have a clear yes or no. And then hey, Firefox was actually collected for wake word application. So these are the 14 words that were collected. And the question that I just answered is why these words? I said it's cross-linguistically similar. That was kind of my original interest in this. But also they're practical for applications. IVR, interactive voice response systems, like you call your bank, and you don't usually talk to an operator right away. Usually they ask you to say out your credit card number. And you do that with a kind of simple speech recognition system that can recognize digits. So this data can be applicable, useful for these kind of applications right out of the box. And why these languages, as we talked about earlier, community interest. These are languages that have people that are really active. So these are the languages we have, and these are the number of hours we have. These are rounded, so the hours, where it's reported in hours, it's rounded to the nearest hour. Where it's reported in minutes, it's rounded to the nearest minute. And you can see we have a kind of long tail here, but we do have some languages where we've got actually a lot of data, like Spanish, 56 hours of just these 14 words is a lot of data. And I'm really excited to see what you're all going to be able to do with this. And then where we've got fewer minutes, I think these are languages where you can really try to go for efficiency and see if you can get some interesting training techniques here. But for the higher resource languages, you can do some interesting things without a lot of tweaking, I think. So the audio, what does it look like? These are MP3 files. They have one channel. They have a sampling rate of either 48 kilohertz or 44.1 kilohertz, 16-bit, and the bit rate does vary, but it's usually around 64K. And so one kind of common question that we get is, why are you using MP3s? Why aren't you using WAV files? MP3s are lossy, WAVs are lossless. The basic question is, the basic answer is, we need to collect audio from a lot of different devices, from a lot of different browsers, from over a lot of different internet connections. And basically the conclusion we came to was for the web, universally MP3 makes more sense. But that being said, don't worry if you're an audiophile. You actually, for these kinds of applications, if there's some noisiness in the audio that has to do with the lossy encoding, that's actually not a bad thing. So now I'm going to basically just walk you through what it looks like when you download the data, what it's going to contain. Whenever you go to download data from Common Voice, you get a friendly warning. It says how many gigs the data is going to take up. I will tell you, if you're going to download English or Spanish or Kinyarwanda or one of these big languages, it can take a while. But the target segment's corpus is nice. It's only 3 gigs. And yeah, let's talk about that. So all of the data on Common Voice is going to be here. It's commonvoice.mozilla.org/datasets. And the target segments corpus that we're talking about in particular right now it's pretty hard to miss. It's the top of the page. It's got this nice black banner and fancy design. And you just click the download button. That's it. When you get it, what does it look like? You're going to get a tarball that's going to look like this. So when you extract that, you get 18 subdirectories. That's it in the top directory. Each of these is a 2-letter ISO code for the language. So we have Arabic, Catalan, Welsh, German, English, Esperanto, Spanish, Basque, French, Indonesian, Japanese, Dutch, Polish, Portuguese, Russian, Tamil, Turkish, and Tatar. So these are the 18 languages we have. If we look in, we get this. We've got 6 files, 6 TSV files, and 1 new subdirectory. This directory, clips, contains the audio. This is where all of the gold is. These are all the same MP3 files that I talked about earlier. So now for the TSV files, there's kind of 2 sets of them. There's these 3, which are invalidated, other, invalidated. And these contain information on the voting that happened on the platform. So invalidated data has been voted down enough times to be basically thrown out of the corpus, you could say. Validated has been voted up enough times to be conclusively contained in the corpus. Other are kind of all of the other audio clips that are in purgatory still. They haven't gotten enough votes for either way. So none of those are probably files that you want to directly interact with, but that's what they contain. What you want to directly interact with are these 3. So we've got dev, test, and train, which probably look familiar to you if you've done some machine learning before. These all contain clips from the validated TSV file, but they've been split up. And they've been split up by this tool. It's on GitHub. It's Mozilla/Corpora Creator. That's what it does. It creates Corpora. And if you're interested in, there's a lot of thought that went into this, like how it's split. Basically, the test and the dev samples are statistically determined to be a representative sample of the train set, and you can dive into the stats on what that means to be a representative sample. And also, you can kind of change this if you want. Like some people might say that the splits in the data are sacred and you can never touch them. And obviously, you should not test on your training data ever. That's a bad thing. But if you're have some other scheme for splitting into test, dev, and train, go for it. I will say that something that's very important is that we've made a decision that no human speaker will be present in more than one of these sets. So if you've heard somebody's voice in train, you should never hear that same person's voice in test or dev, even if they spoke a different sentence, because that's a kind of cheating, basically. If you've learned somebody's voice, there's a lot of things with that voice that carry over, and you want to know how well your model generalizes, so you want to test it on different speakers. That's good practice. Yeah, I think that's all I kind of want to say about this. If you want to play around making your own splits, check out Corpora Creator and look at the flags. There's lots of different settings you can play with. So,
Josh, quick question.
Yes.
For when, how do you check for that? How do you ensure?
That is a good question for voices. So that is a beautiful segue. When we look into the TSV files, this is the kind of information we have. For every audio clip, we have information on the client ID, which is going to be highly correlated with speaker identity. So these client IDs. I've truncated them here so they fit on the page, but they're these monster, I don't know, they're 20 or something characters long, anonymized IDs. But you can see here that they do repeat. So we've got information. These store information about not exactly the user, but more about kind of the session on Common Voice and the browser that was used. So I believe that these are cookie-based, and they help us know if somebody sat at their computer and they donated for 2 hours from Firefox, then we can assume that that was one person. So these are not always 100% accurate, but they're pretty accurate. So we have client ID, we have path, which contains information on the file name. We have sentence, so this is what the person read out loud. And this is from the targets segment corpus, the test set for Welsh, I'm pretty sure. So these are Welsh numbers 1 through, I'm not sure, my Welsh is rusty. But we've also got information on upvotes and downvotes, and this is really interesting information. So you might just be looking at the data from invalidated and validated to determine which ones are valid and which ones the person said something different. But here you get more fine-grained information. So we've got number of upvotes, which it has to be at least 2, and the number of downvotes. So if you want to be really strict, you can throw out all of the data with any downvotes, but I don't know. I wouldn't really recommend that. And then we have some information on demographics. So here's something I want to talk about. You see that not every clip in this set has demographic information. That's because this information is purely opt-in, and it's purely self-identified. So somebody can, if they want, they can set up an account. They can set up an account, and they can give us any one or all, or any combination of these pieces of information. So this person gave us information on age, gender, and accent. And that is something that you get through the accounts feature. So if you all went up on Common Voice and you donated, but you didn't make an account, there's no information on your demographic on your demographics in here, because basically we don't have that information. So locale, this is the language. This is CY is for Welsh. And then segment, this is the single word benchmark. It's what I've been calling the target segment. This is basically just distinguishing this specific subset of the corpus from the larger set of the corpus. Okay, so if you're using this data, you probably want wave files, and you maybe want to do some other formatting. So I just wanted to throw this in here really quick. There's this nice little Python script from Mozilla's Deep Speech project that can help you kind of elegantly reformat the data, and it can also help you throw out files that you think are too long or too short. There's some nice flags in there and options that you can use. So I want to quickly talk about, we don't have a lot of time here, demographic data. So as I said, we have information on gender, accent, and age only when it was opted in and only when it was self-identified. When we talk about demographic information, we also have to talk about bias, demographic bias, because data is always biased, especially human data. It was collected by, in a certain way, it was collected by certain people, and certain people were chosen to, not chosen, they opted in to give up their data. So this is something that needs to be kept in mind. So the question is, how is the data biased? So with the Common Voice data at large, we can look at the information we have on gender, accent, and age and start to get a picture. So on average, per language, we have data that is biased towards men. So we have fewer women's voices, or at least fewer people opted in to identify their gender as woman in this data than men. So we don't have information on about half the people in the data, let's say. But from the people that did give us their information, we know that we've got a skew. And this kind of tracks with the demographics we find in the larger Common Voice set. So this doesn't mean that the data is not useful for women. It doesn't mean that it's not useful for other genders. It means that we need to pay attention to these. And also when we talk about ages, this is probably not surprising. We find that most people who donated were in their 20s. And we have almost no data from anybody over 40. So again, this doesn't mean that the data is not useful for anybody over 40, but it does mean that this is something you need to keep in mind. If you're interested in these kinds of questions on demographic bias and speech technology, I would say that you should take a look at this paper that I recently put out. And we've got data and tools for kind of diagnosing demographic bias in speech applications here on GitHub. So what's next? This is a project that is alive. It's a project that is growing every day. It's growing in the number of languages. It's growing in the number of hours of voices. It's growing in the demographic makeup. And the more you donate, the more useful it becomes. So really encourage you to go promote the project, use the data. You'll find that this kind of data for free out there is pretty unique. So I hope you'll find it useful. And remember, this is Creative Commons 0 license. So you don't have to worry about using this data for for commercial purposes. You don't have to worry about using it for research. It is CC0. It's public domain. You can do whatever you want with it. And thank you.